Hello everyone, let's discuss another performance indication of transformer, that is voltage regulation. So what is the definition for voltage regulation? So the definition for voltage regulation is what? The voltage regulation may be depends on change in secondary terminal voltage from no load to full load at specific power factor. Wait a minute. So no load to full load at specific power factor of load, and the change in percentage of either no load secondary terminal voltage or full load secondary terminal voltage. So this is the referred to secondary equivalent circuit. With respect to change in load only, we are going to get the change in terminal voltage, because with the load changes, obviously the secondary rated current changes, obviously the secondary terminal voltage changes. So we are having two different formulas for voltage regulation, that is change in secondary terminal voltage from no load to full load. No load to, that is E2 is nothing but no load secondary terminal voltage, right? Up to E2 only there is no load. After, whenever we have a load, obviously because of that load there is a current through that load. Say therefore, in addition with that, we are going to get the terminal voltage. That's why no load terminal voltage minus E2 by what? At specific power factor of load, and the change is expressed in percentage of either no load secondary terminal voltage or full load secondary terminal voltage. So with respect to no load secondary terminal voltage, that is the formula. With respect to full load terminal voltage, this is the formula. Okay, so this is the formula for that. If reference is taken as secondary no load terminal voltage, this is the formula. If the reference is taken as secondary full load terminal voltage, that is V2, this is what? E2. So unless and otherwise specified, regulation in the sense regulation down only. So this is what? Regulation down. If with respect to no load secondary terminal voltage, that is E2, that is regulation down. If it is no load, full load terminal voltage, that is regulation up. For example, if examiner didn't provide any data which is referred to down or up, you have to choose down only. By default, you have to select a regulation down formula only. So by default, we have to go with the regulation down formula, that is voltage drop in transformer at specific power factor of load with respect to what? No load secondary terminal voltage. Simply, the voltage regulation means percentage voltage drop in transformer at specific power factor of load, right? The voltage drop at specific power factor of load can be determined as from this circuit. So this load is varies, obviously the secondary current varies, we are going to get different terminal voltage. So from this we are going to get the voltage balance equation as E2 plus E2, which is equals to resistive branch R02, the current through that, the current through that branch is nothing but what? I2 R02, right? E2, which is equals to I2 R02 plus again I2 X02 plus V2, right? V2, let us take this is imaginary. From this voltage drop E2 minus V2, which is nothing but voltage drop, which is equals to what? I2 R02 Sj I2 X02, right? This is the voltage balance equation from this circuit. Let us kindly change. This is E2 minus V2 by E2. Now we have to calculate voltage regulation at lagging at specific power factor. Now we have to discuss with respect to lagging power factor. What is the equation for us? That is E2, which is equals to V2 plus I2 R02 plus I2 X02. Clear? So from this, for lagging power factor, what is the condition? I2 lags V2 by how many angles? Phi 2. Therefore, first we have to draw the phasor or reference, right? Let us take the reference as voltage, right? Then current lags, this is current, lags voltage by what is the angle? Phi 2. Clear? Then what about I2 R02, which is in phase with the drop, should be in phase with current, right? This is nothing but what? I2 R02. Clear? The drop, voltage drop is always in phase, voltage drop across resistor is in phase with current. Clear? This is I2 R02. So V2 completed, I2 completed, I2 R02 completed. Then what about I2 X02, which is quadrature with I2 R02, which is quadrature with I2 R02. Finally, this is what I2 X02. Then what is the resultant no load secondary terminal voltage? The no load secondary terminal voltage is nothing but this. Now this is E, right? So from this, E should be equals to V2 plus I2 R02 plus I2 X02, and this is the phase angle phi 2. Therefore, right? So from this position, let us take the points here. Let us take this. This is, let us take O, this is A, this is B, this is C, this point is D, and this is E, this is F, right? So from this, what is phi 2? So this is phi 2, obviously this is also phi 2 only, this is also phi 2 only, right? So this is BD, the triangle is what? BD and DE. So we have to get what? From this, OA should be equals to what? OA should be equals to what? E2, comma, OB should be equals to what? V2 only. So OC should be equals to what? Component of E2 along V2. The component of, let us take this E2 along V2, right? This is the actual graph, but this magnitude is neglected. Up to this point only we have to consider, because the component of E2 along V2 should be properly scaled, but for better to make the calculation easy, we have to extend this component from this point to this point. So the component of E2 along V2. So therefore voltage drop is nothing but what? E2 minus V2, which is equals to what? OA minus OB, right? E2, it is nothing but what? OA, OB, OA minus OB, right? OA minus OB is nothing but the component voltage drop, which is nothing but, we can write OC minus OB. You can write, sorry, this is nothing but which is equals to what? Sorry, not like that, because we have extended the component of E2. Therefore, with respect to this axis only we have to take. So E2 minus V2 should be equals to what? OC minus OB. OC minus, so with respect to this axis only we have to take, because we have extended the component of E2 along OC. That's why E2 is nothing but what? This is extended to this point. That's why OC minus 0, OB is nothing but V2. E2 minus V2 should be equals like this, which is equals to what? BC, right? BC. Therefore, voltage drop, which is equals to what? BC only, right? Which is equals to what? BC is nothing but what? BD plus DC. BD plus CD. And from this, CD should be equals to this magnitude and this magnitude is equals. Therefore, BD plus CD, which is equals to BD plus EF. Clear? Therefore, or you can write E2 minus V2, which is equals to voltage drop. We have to get from triangle BDE. From this triangle BDE, cos phi 2 is equals to what? Cos phi 2, which is equals to BD by adjacent side by hypotenuse, that is I2 R02, right? From this BD, which is equals to what? I2 R02 cos phi 2. Clear? Like that, from triangle AEF, from this triangle AEF, this is also nothing but phi 2 only. From the triangle sin phi 2 is equals to what? Opposite side is nothing but what? EF by I2x02. From this, EF should be equals to what? I2x02 sin phi 2. Then we have to substitute BD and EF in this equation. Therefore, from 1, what is the magnitude? E2 minus V2, which is equals to, in place of BD we have to write I2 R02 cos phi 2 plus, in place of EF we have to write I2 x02 sin phi 2. This is the voltage drop in transformer, right? Voltage drop in transformer during lagging condition. Then what is the formula for voltage regulation? Voltage drop in transformer with respect to load and no load to full load, with respect to no load terminal voltage. Therefore, voltage regulation, which is equals to what? E2 minus V2 by E2, which is equals to what? I2 R02 cos phi 2 plus I2 x02 sin phi 2 by E2 during what? During lagging condition. This is the voltage regulation formula during lagging condition. Now we have to get the voltage regulation during leading power factor. So we all know that during leading power factor, I2 leads V2 by phi 2. I2 leads, what is that? I2 leads V2 by phi 2. Therefore, what is the equation? We all know that E2 should be equals to V2 plus I2 R02 plus I2 x02. So for this, what is the phasor we have to consider? This is V2, and what about I2? I2 leads, right? I2 leads, obviously. This is I2 R02. Clear? Then what about I2 x02? This is I2X02. Then what is the resultant terminal voltage under no load? This is E2, right? Or you can write, you can draw. For better understanding, I can extend the components. The angle should be very less. Let us take this I2, right? Now this is taken as I2 R02. Now what about the axis of I2 X02? Let us take, this is quadrature with I2 R02, right? This is about I2 X02. Then what about E2? This is E2. Clear? Then I have to draw the component of E2 along this. We have to calculate again from this point to this point. That's it, right? Therefore this is phi 2, this is phi 2, obviously this is also phi 2. Clear? Now we have to notate 0, this is A, this is B, this is C, this point, and this is D, this point is E, and this point is F. So the component of E2 along OC is nothing but what? Along OC is nothing but what? BC. So from this, voltage drop of transformer during leading condition is what? Voltage drop should be equals to, which is equals to BC only, right? BC, this is the voltage drop. Along OC is nothing but OC only. The component of E2 along OC is nothing but simply, it is nothing but OC, that is OC minus OB is nothing but BC. So E2 minus VT is nothing but what? BC only. This is the voltage drop up to from this point to this point E2. E2 minus V2 is nothing but what? OB. So obviously the voltage drop is nothing but what? BC only. So BC, which is nothing but what? BD minus CD, right? Therefore which is equals to BD. What is the value of CD? Which is nothing but EF only. CD should be equals to this and this, magnitude is same. Therefore from the triangle, first we have to consider BDE. Sorry, what is that? BDF. Triangle BDF. Cos phi 2, which is equals to what? BD, right? Adjacent side by I2 R02. Like that, triangle AEF. Just these are the total mathematical approach. Just go through this. Now this is what? EF by I2 X02. So from this BD, which is equals to what? I2 R02 cos phi 2, and from this EF should be equals to what? I2 X02 sin phi 2. Therefore voltage drop during leading power factor is nothing but what? Therefore voltage drop, that is E2 minus V2, which is equals to what? In place of BD you have to write I2 R02 cos phi 2. Now it is minus, and then I2 X02 sin phi 2, and voltage regulation is what? Which is equals to E2 minus V2 by E2, which is equals to what? I2 R02 cos phi 2 minus I2 X02 sin phi 2 minus by E2. So this is what? Leading. So in lagging condition we are going to get plus, in leading condition we are going to get minus. That is only the difference. So this is the formula finally we got, right? What is that? Therefore the voltage drop at specific power factor of transformer, that is E2 minus V2, which is nothing but this, where plus and minus, plus is for leading and minus is for sorry plus is for lagging. Plus is for lagging and minus is for leading. Okay, therefore voltage regulation is nothing but what? E2 minus V2 by E2, that is I2 R0 to cos phi 2 plus or minus, depends upon the specific power factor. We are going to get plus or minus. If it is lagging, go with plus. If it is leading, go with minus. I2 X0 to sin phi 2 by E2. So from this I2 R0 to by E2, we can write like this, into cos phi 2 plus or minus I2 X02 by E2 sin phi 2. So we have to write one important note. Percentage resistance drop, which is equals to I2 R02 by E2 into 100, like that. Percentage reactance drop, which is equals to what? I2 X02 by E2 into 100. Therefore percentage regulation, which is multiplied by 100, that's why this is percentage regulation. Therefore percentage regulation should be equals to percentage resistance drop into cos phi 2 plus or minus percentage reactance drop into sin phi 2. This is very important formula, all of you remember this formula. Percentage regulation is what? Percentage resistance drop, that is nothing but what? I2 R02 E2 into 100. Percentage reactance drop, that is what? I2 X02 into 100 into sin phi 2, where plus is what? Lagging. When lagging power factor, you can use plus sign. When it is leading power factor, you can use negative sign. Then tell me, in which side we are going to get maximum voltage regulation and which side we are going to get minimum voltage regulation? So for plus this drop plus this drop, obviously we are going to get maximum voltage regulation under lagging. But coming to leading, this drop minus this drop, obviously we are going to get zero regulation also. If this drop should be equals to this drop, obviously we are going to get zero regulation. That's why we can write minimum voltage regulation in this leading power factor. Always we are going to get minimum voltage regulation as well as zero regulation also. So we are going to get the condition for maximum voltage regulation. So at maximum regulation, the voltage drop in transformer is maximum and secondary terminal voltage is minimum for a given applied voltage. That is E2 minus V2 should be equals to maximum. That is the case. E2 minus V2 is very high. What is that meaning? That is this secondary terminal voltage, that is V2 is minimum. If V2 is minimum, obviously E2 minus V2 should be equals to maximum. Therefore, in order to get that condition, this is the formula. Differentiation of regulation with respect to secondary phase angle, which is equals to 0. We all know that what is the formula for regulation of a transformer is maximum only at what? Leading power factor. Because what is that? What is the reason? Because we have positive sign. Therefore the maximum voltage regulation is nothing but what? Differentiation of regulation with respect to secondary phase angle, which is equals to 0. Therefore from this differentiation of regulation with respect to d phi 2, which is equals to what? This is percentage r. What about this? Minus sin phi 2, right? Plus percentage reactance drop into differentiation of sin phi 2 is nothing but cos phi 2, which is equals to 0. So from this we can write percentage r sin phi 2 should be equals to percentage reactance drop into cos phi 2. From this tan phi 2 is nothing but what? Percentage r by percentage x, right? From this tan phi 2 is nothing but what? Percentage resistance drop by percentage reactance drop. We know that percentage R should be equals to what? I2. Percentage resistance drop is nothing but what? I2 R02 by E2 into 100, and percentage reactance drop is nothing but what? I2 X02 by E2 into 100. Therefore, tan phi 2, which is equals to what? I2 R02 by E2 into 100 by I2 X02 by E2 into 100. So from this, I2 E2 gets cancelled. Finally, we are going to get tan phi 2 equals to what? Tan phi 2, which is equals to what? R02 by X02. Therefore, finally, tan phi 2, which is equals to what? Percentage resistance drop by percentage reactance drop, which is equals to secondary resistance by secondary reactance, refer to secondary. Like this, we are going to get the tan phi 2. So, from power triangle, what we are going to get? What is the power factor? From this is what? R02, this is what? X02, and the resultant is what? Z02, right? And this is what? Phi 2 only, that is tan phi 2, R by X, right? R by X, R02, X02, Z02. What we have? That is, sorry, here it is X by R, right? That's why I got different value. This is X02, this is R02, X by R. Kindly make the modifications. From this, tan phi 2 is nothing but what? X by R, right? That's why this is X, this is R, this is X02, R02, percentage X by percentage R, percentage, that is X02 by R02. Now it's clear. Opposite side is nothing but what? X02, and adjacent side is nothing but R02, that is tan phi 2. Then from this, what is the power factor? What is the power factor of load? Cos phi 2 should be equals to what? R02 by Z02, which is equals to what? Percentage R by percentage Z. That is the power factor of maximum voltage regulation during lagging condition. That is the power factor of transformer at maximum regulation is nothing but what? Percentage R by percentage Z, that is lagging. Okay, like this we have to get the power factor during maximum voltage regulation. Now we have to get, before that, the value of maximum voltage regulation is what? Now we have to calculate the value of maximum voltage regulation. So maximum voltage regulation is occurred during what? Lagging condition only. Then what is the value of maximum voltage regulation? This is the derivation for the power factor, that is percentage R by percentage Z. Like that, sin phi 2 from this power triangle should be equals to what? X by Z, right? This is the sin phi 2. So we all know that what is the formula for maximum voltage regulation? This is from this percentage R into cos phi 2 plus, why plus? Because maximum voltage regulation during lagging condition only, that's why you have to consider plus. Now reactance into sin phi 2. So in place of sin cos phi 2 we have to substitute this value. In place of sin phi 2 you have to substitute this value. So finally after substitution we are going to get the maximum voltage regulation is nothing but percentage Z only. This is during lagging condition. This is during maximum voltage regulation is possible only during lagging condition, and the magnitude is what? Only percentage Z, percentage impedance drop only, right? Next, when we are going to get the zero voltage regulation, only we have maximum regulation, zero regulation. So we all know that during leading condition percentage R drop into cos phi 2 minus percentage x drop into sin phi 2. So there is a minus sign during leading condition, right? Obviously, for example, this magnitude and this magnitude is equal. Obviously, we are going to get zero voltage regulation, right? So from this we can conclude that the zero regulation can be occurred only during leading power factor only. So if resistance drop is equals to reactance drop, the zero voltage regulation will occur and it is possible at leading power factor only. So at zero voltage regulation, the primary and secondary voltage are maintained at their nominal values. So this drop should be equals to this drop. Therefore, the voltage regulation should be equals to 0 for what? Leading only. That's why we have to consider negative sign. That's why we have to consider negative sign. Percentage R cos phi 2 minus percentage X sin phi 2. So from this, what is the power factor during zero regulation? So which is 0 percentage R cos phi 2 minus percentage X sin phi 2. From this, what is tan phi 2, which is equals to, tan phi is equals to what? Percentage R, which is equals to percentage X, sorry, from this we can get percentage R by percentage X, right? Tan phi 2 should be equal to what? Percentage R by percentage X, which is nothing but what? R02 by X02. This is the phase angle with respect to tan. So what is the power triangle? We all know that the power triangle is what? With respect to this, this is Z02. So this is R02, this is X02, and the phase angle where we have to provide that phi 2, where we have to provide that phi 2. Tan phi 2 is nothing but what? R02 by X02. Opposite side is nothing but R02. Therefore, this is phi 2. Therefore, from this tan phi 2 is nothing but what? Opposite side R02 by adjacent side X02. Satisfied? Like this we have to draw the power triangle. From this, what is the power factor? What is the power factor which is equals to power factor which is equals to adjacent side X02 by hypotenuse, that is percentage X by percentage Z. This is the power factor during leading, right? This is the power at zero regulation. The power factor is what? Percentage X by percentage Z leading. Very simple. So these are the basic summary points. See, full load voltage regulation formula is nothing but what? Percentage R into cos phi 2 plus or minus. When we are going to place? When plus lagging, when it is minus, that is leading. Clear? Okay. When, what is the value of voltage regulation at different fractions of load? Just we have to multiply with X. At half of the load, X should be equals to 1 by 2. At full load, X should be equals to 1. At 3 by 4th of full load, X is equals to 3 by 4. For different fractions of load, we are going to get different voltage regulation. Just you have to multiply with the fraction X. From that, what is the voltage regulation at UPF? Percentage R only. Since what is the condition? Cos phi 2 should be equals to 1 and sin phi 2 should be equals to 0. Only at unity power factor, the value of voltage regulation is nothing but percentage R. At UPF, what is the maximum? What is the efficiency? Maximum voltage maximum efficiency is possible at UPF. Then the power factor of transformer at maximum regulation is nothing but what? At maximum regulation is what? R by Z. That is, the voltage regulation is maximum during lagging condition, and this is the power factor during lagging condition. The value of maximum regulation is what? Percentage, right? We have derived this. Like that, the value of zero regulation is what? Is possible at leading only, and this is the value of power factor. So now we have to get the graph. This is the point where UPF Okay, this is leading. This region is what? Let us take leading. This region is what? Lagging. Okay, so let us UPF. Therefore this is 1, this is 0, right? 0.2, 0.4, 0.6, 0.8, like that. 0.8, 0.6, 0.4, 0.2, this is 0. 0 lagging power factor, 0 leading power. This is ZPF lead, right? This is ZPF lag. Clear? Okay, next we have to get the curve. At UPF, what is the value of voltage regulation? At UPF, the value of voltage regulation is what? Only percentage R only. Let us take at this point, this is the value of percentage, some value of voltage regulation is there, right? This is the voltage regulation. Okay, some finite value of voltage regulation at UPF, that is percentage R. At maximum voltage regulation, what is the power factor? That is R by Z. R by Z. At leading, the zero regulation is what? X by Z. What is zero regulation? Zero regulation is possible only at leading only. Maybe this is the, so maximum voltage regulation is what? Let us take, this is percentage. The value of maximum voltage regulation is nothing but what? Percentage Z, right? This is the point. So based on this, we are going to get the graph like this. So the maximum voltage regulation is possible at this point, and the value is what? Percentage Z. And the minimum voltage regulation is at what? The minimum voltage regulation is what? At leading power factor, that too, that is 0. Okay. So this is the exact graph, and this is voltage rise is possible at leading power factor, and voltage drop is possible at lagging power factor. We all know that. And during lagging condition, we are going to get maximum voltage regulation, and during leading condition, we are going to get minimum voltage regulation. And this is the point where we have to get zero voltage regulation, and this is the power factor, right? Percentage X by percentage Z. And voltage regulation at UPF is nothing but what? Percentage R. That's why we have some finite amount of voltage regulation at this UPF point. That's why this is the finite amount of voltage regulation is possible at UPF. And this is the point where we have to get the maximum voltage regulation, and this is the power factor R by Z. And this is the value of maximum voltage regulation, that is what? Percentage Z. And this is the value, approximately this is 0.92. Approximately the power factor at zero voltage regulation is what? 0.92. And this is the power factor. Percentage X by percentage should be equals to 0.92. Okay, this is the regulation curve of a transformer. Now we have to discuss one important problem regarding this. Before that, summary. That is, voltage regulation is maximum during which type of load? During lagging condition. That is, with respect to lagging load, we have maximum voltage regulation. Voltage regulation is 0 during leading load. That is, whenever we have leading load, we can get 0 voltage regulation or minimum voltage regulation, right? Minimum when we have leading load, right? So we all know that voltage regulation is percentage R only when what? At unity power factor. So among this, which one is more preferable, desirable? 0 is most desirable voltage regulation. This is undesirable. You are not going to get maximum voltage regulation. This is only desirable. So we have to keep voltage regulation as minimum. Efficiency we have to keep more maximum. That is for any transformer, keep transformer is maximum and voltage regulation minimum. Therefore, these are the most desirable conditions. So this is about voltage regulation of a transformer. Thank you.